Alright, so we are going to begin our interactive math notes for trimester 1. Go ahead and put your name and number on the front of this so we can always return it to you. Okay. And here's another place to put your name. So you want to write your first and last name in cursive. Then the next page, what we have is our table of contents. So if we need to find any particular page, we can look for whatever that lesson is or that standard is here. So we're going to start out with our mathematical practices, our reference page, mathematical practices, and problem solving. That's going to be pages 3 and 4. So we turn over. And here, down here, it says page 3, way down there. Alright, so for this, just kind of going over what these are. Standards of mathematical practice. What these are 8 skills or things that successful mathematicians do all the time so that they are able to be successful. Successful mathematicians aren't successful just because it comes easy to them. It's because they do these 8 practices. So our practice number 1 is make sense of a problem and persevere in solving them. Keep on going. Another way to look at that is understand and persevere. I can make sense of problems and not give up when trying to solve them. So the number one thing that makes you successful in mathematics is you keep going. You keep trying. No matter if it seems difficult or not, the only way to be successful is to keep going, to keep persevering. Okay, then we have number 6, which is interesting that we go from 1 to 6, but you'll see why in just a little bit. This one is attention to precision. 120 minutes is equal to 2 hours. You want to check your work. Does that make sense? We're going from smaller units to larger units. You're looking, is the language precise? Is the information, did the work I do, was I careful in that to make sure everything was precise? Attention to precision. I can review my calculations and strategies to see if they are correct and also to make sure you use the correct terms. Now these two together we call the overarching habit of mind. Because this is not actually anything you do, it's just how you make sure your mind works. It's that growth mindset. You're going to keep going and you're going to make sure it's precise. So it's just a habit of your mind. It's that growth mindset that keeps you going. Okay, so now we look at 4 and 5. Here we have model with mathematics. So here's a model with a number line. Here's models with equations. Show your thinking. When it says to explain, to justify, this is the kind of thing that you're doing. You're able to use a model to show what you mean. Model with mathematics. I can clearly show my work using diagrams, words, symbols, and pictures. So you can show what's happening with the model, kind of like with our daily fraction, we use a model. Number 5, use appropriate tools strategically. So 3 times 2 equals 6. We have 3 blocks and 2 blocks, so we're using an array here to prove that there's a total of 6 boxes. Now some are kind of light, but they really are 6. Use the right tools. Okay, strategically use tools. I can select and use the appropriate tools to help me solve problems. And so these two together we call modeling and using tools. So these are other practices. You have that growth mindset, you keep persevering, you attend to precision, but you also can use things. Math is based on real life, real world, hands-on things. So if you can use a model or some tools to show what is happening in the problem you're doing, then those are also practices. You should be able to show what you're doing, either with a drawing or actual tools. So those are two more practices. Then down here we have number 2, reason abstractly and quantitatively. Think what makes sense. Okay, so here we're looking at what would make more sense in the problem. Logic and reasoning. I can use words, numbers, logic, and reasoning skills to help me solve problems. There are lots of math problems that I don't even have to fully solve because I can reason it out. I can think logically about it and come to a reasonable solution and have done no work at all. Just what is reasonable, what is logical in that situation. I'm sorry this didn't copy well. It was too light on this drawing. But justify and critique, talk and explain. So this would be like our number talks where you explain your thinking, but you could also be able to find where the problem is in somebody else's argument to be able to critique them in a respectful way. So justify and critique. I can justify my strategies and evaluate if the ideas of others make sense. So that's what these are doing. So here we have 2/4. This person says equals 1/2. This person agrees because this is cut into 4 pieces and shows 2. This is cut in half and you have the same amount shaded in, so they agree. This is called reasoning. And explaining. You have to know why an answer is correct, why it makes sense to be correct, and you have to be able to explain it or justify that. If you're not doing that, then you need to go back and maybe look at a model, see if you can show it with a model or a tool to then be able to explain it in words. Okay, because these are all very important to being successful in mathematics. Number 7, look for and make use of structure. So here, 8 plus 4, well, I could take 2 of these, put it in here, and I get 10 with 2 left over. Well, that's a way of saying 12. So you can decompose and change things to make it a little easier. Use the patterns or connections. Utilize structure. I can use the structure of a problem to help me find the answer. Okay, here, look for and express regularly in repeated reasoning. See the pattern or connection. Math is a science of patterns. There will always be some kind of pattern. If it isn't shapes, it'll be with numbers that can help you predict what's going to happen coming up. So utilize patterns. I can find and use mathematical patterns to help me solve problems. Okay, and this we call seeing structure. And generalizing. So you see a pattern, and it means you can come up with a generalization or a rule of something that should happen next or coming up. Okay, so these are our 8 mathematical practices that we're going to be continually practicing, all of them all throughout the year in different ways. Okay, now let's turn the page and look at our problem-solving strategies. All right, now our problem-solving strategies and skills. So something we'll be using all throughout the year is called cubes. It's problem-solving annotation. Just like we do in our close reading, this is basically close reading of our problems. And first we circle the numbers. Even if they're in word form or other forms, we just always circle numbers. Underline the question. That way we know exactly what's being answered or asked, so we can answer that question. If you don't do that, you may answer a question that's not being asked. You may have a great answer to a different question. So we underline to make sure we know and double check what we're being asked to do. Box. We put a box around. Keywords. The keywords. Any important words like inches, feet, times, multiply, double, half, any of those keywords that gives us a clue of what we're going to do, grouping, multiplying, any of those will be what we want to put a box around. Okay, we will not always do this, but eliminate. No, I forgot a word. Eliminate. E-L-I-M-I-N-A-T-E. Unneeded information. Sometimes problems just have so much in there to give you background and like just extra that it can distract you from what you're actually doing. So you can just cross it out so you don't even have to worry about it because it's just distracting. And then the last one is solve and check. So those are our steps and our annotation that we do when we come across a word problem. Now we have some strategies here for problem solving. Drawing a picture. This is one of the best methods when there's a problem and you're not sure what to do, where to go, is to represent it in a drawing, and that can help you to understand. Use a model. So you can either do this as a drawing or with hands-on blocks or whatever you may need to move around to actually see what's happening. Solve a simpler problem. Well, if you don't know 6 times 4, well, maybe you could break that apart, do 3 times 4, 3 times 4, and add those together. A good strategy I like to use instead of doing 6 times 4 is 5 times 4, because I'm really good at my 5s. That's a much simpler problem. 5 times 4 is 20, and then I just add another group of 4, and I get 24. So 6 groups of 4 is 24, because I have the 5 groups, and add one more. So you just find something similar and see if it works, and then you can apply it to something more challenging, because if it works for the simpler numbers, it should work for the more challenging ones. Solve an equation. So this is what we'll be working on more and more this year, is being able to solve equations, write equations and solve equations. Sometimes you can guess and check. Guess an answer, check if it works. With this strategy, you make a lot of different guesses to narrow down what the actual answer is. Here, make an orderly list. This is another thing that you do. You list every option out, or check through to make sure you didn't miss anything, and it gets you to the solution without in a faster way, usually because you didn't skip something. Working backwards. So sometimes you can work from the answer and look at the work going the other way to see. This especially is good with time, because if you know what time you started something and what time you ended something, you can work backwards to figure out the amount of time. Or if you know what time you ended and how much time each item took, you can work backwards in time to figure out how you started. Look for a pattern. That was also one of our mathematical practices. Math is all about patterns. Looking for patterns, using that pattern to come up with a way to predict what will be next. All right. Here is questions then, problem-solving questions for identifying operations. So the first question we're always going to ask when we come across a word problem is, do you know the total amount of items? If the answer is no, then you are going to add or multiply to find the solution. When you don't know the total amount, you need to add or multiply, because then you're putting them together, you're joining everything together, either different amounts or the same amount quickly, to figure out what the total is. So if you don't know the total, you're going to add or multiply. To know which one to do here, do you have items that repeatedly add, or two or more different amounts to put together? So if you're repeatedly adding the same amount or the same group of numbers, same amount, you're going to, so repeated addition or joining equal groups is multiplication. But when you are putting different amounts together, you're going to add. Okay, here. Question number 1, do you know the total amount of items? If the answer is yes, if you know the total, that means you're going to subtract or divide. I have 20 chairs, I need to make even rows, I'm going to divide. I have 20 chairs, I need to give 2 to Fred, you're going to subtract. If you know the total, then you're going to subtract or divide to solve that problem. Are you putting the items into groups or finding differences? So we're working on equal groups or finding differences. Making equal groups, like in our daily fraction. Making equal groups, we'll divide. Making unequal groups or finding a difference. Like if we're trying to figure out how much taller somebody is, well, you would, why did I put a G? Finding a difference. If we were looking at how much taller somebody is, then you take away the height that's equal to see what's left over. That's that difference. Okay, so these are just things that we're going to use throughout the year. These are going to be tools to use when we're doing our word problems. So thank you for looking over the reference pages with me, and we'll start our lessons next week. Thank you for joining me.